All right, folks, welcome. I'm going to talk to you about how I imaged the asteroid 1999 Uniform Juliet. And I think it's actually Uniform Juliet 7. I think 99 was the year it was discovered, and maybe Uniform Juliet is some sort of designation used to identify which asteroid in that year was discovered. I'm not sure, but that's what it's called, and I'm going to talk you through the process. Not necessarily the setup of the scope and the camera. It's no different than you or I would set up to shoot DSOs, right? So we set up our equipment and take long exposures our equipment allows with an ISO that maximizes exposure, minimizes noise, and then process it and go from there. So that's what I did. I ended up, and my standard, you can watch the videos of my channel, standard setup, 16-inch Orion Dobsonian telescope with a Sony QX1 mirrorless DSLR that I can control via Wi-Fi. So I ended up only taking 8 subs. I think these were 20 seconds each at about 1600, maybe 2000 ISO. And again, we're shooting an asteroid, a pinpoint target. So I'm not too worried about, really speaking, noise. It's not like we're shooting nebulosity, in which there's a very high chance that during noise removal we'll actually take out some of that nebulosity. These are, generally speaking, pinpoint targets, these asteroids. And so I will set a higher ISO. I can't recall why I only have 8 subs. But you would want as many as possible, because remember, the higher the number of subs, the greater your signal to noise ratio when you stack these. So these were registered or aligned, whatever term you want to use, in PixInsight. Then I integrated them, or that's what PixInsight calls it, or other software we call it stacking, to end up getting this image here. And then I exported a JPEG version of the image. And this is what it looks like. So here is our JPEG. A final image after stacking them. And I can't tell the difference between an asteroid and a very dim star. Obviously, sometimes on DSOs, that's kind of fuzzy looking, whereas these are pinpoint, if that's what you want to call it. So obviously we got a galaxy there. There's a barred spiral galaxy here. I can actually make out the bars in the spiral, so that's pretty cool here. In fact, you probably know this. You could just point your scope anywhere in the sky and take a series of pictures and process them, and you're going to have a ton of galaxies in here. Here's another one. But the point is, I don't know where that asteroid is. It's somewhere in here. So that's really the challenge. It's not that challenging to point a scope somewhere in the sky and take pictures and process them. The challenge is, how do I identify this asteroid, an extremely dim asteroid, at that? So that's what we're going to talk about. First of all, how did I pick this asteroid? Well, if you go to inthesky.org, and I meant to have that that tab called up for you. Let me call up another one here just to make things quicker. Okay, we'll come to it here in a second. So if you go to inthesky.org, there's some tabs here. I can go find comets, planets. I can call up sky diagrams. But if you click the asteroids tab, and sometimes their website takes a little while. I should have done this prior. In fact, I'm going to hit pause real quick, not waste your time. Okay, so we're back. Sure enough, it did take a while. But what's cool about this site, you can tell it where you're at, right? Because when it's visible, whether it's relatively close to the horizon, where it's going to be coordinate-wise and all that depends on your location. So you can tell it where you live, where you're from. But you can go through this list here and say, oh, okay, I know my scope can reasonably image an 11 magnitude object. So here's an asteroid, and it's going to be visible, by the way, from 10:13 at night till maybe an hour and a half, so perhaps I can image that thing. And here's the constellation it's in. I know Leo is nice and bright and prominent around midnight at my location, so this may be a viable target. That's one way to go and look for asteroids. Now, notice this chart stops. I don't know if it's got a limitation on it, but it goes all the way. It stops at 13.62. Well, our target for this night, this 1999 Uniform Juliet 7, is much dimmer than that. So, and by the way, notice the limit of 200. Maybe it only lists 200 of the brightest. I don't know. But you can go here to figure out your target asteroid. That is not what I did on this particular night. I just wanted to show you this option. What I did is I went to Stellarium. And if you're not familiar with it or you don't use it, I recommend getting. This is an awesome program. I control my telescopes, both of them, through this. I can do it at the same time. I have a video posted on how to do that. But I sat in the warmth of my car while it was freezing out on the plains, fairly cold, and I controlled my scope with Stellarium. So if you go to the search window, and of course you can put in moon, and that's what it's focused in on right now. But if you go to this other part here, you can look for these objects. So, and if you know the name of the asteroid like series, you could put that in here and it'll slew to it. But if these are kind of some off the wall objects, you can come here to list. And in this drop down, there's quasars and asterisms and how you say it, blazars. Some of these terms I never even heard of. Bipolar nebula. You go to the Bernard catalog, but I select asteroids. And then I just started scrolling through here, and I said to myself, these are asteroids, but they're probably very dim. I don't even know what these numbers mean. But I just kept scrolling. I said, oh, but if it's got a name, it's probably a little bit brighter. I'll have a higher probability of success. So I would pick, for example, Icarus and find out it's not even above the horizon while I'm going to be out in my dark sky site. So bottom line is I just scrolled through these, and I did several asteroids in the same night. But of course, we're talking about 1999 Uniform 7. I actually did this one. I tried that one, didn't work. I'm going to go back and try to redo it. But anyway, the point is, one of the first ones I came across was this one here. And I said, well, it's got a bunch of numbers, but it's got some other stuff here. So maybe it's a little bit more prominent, a little brighter. So I said, let's go see where it is. So I clicked on it. Stellarium slews to it, of course. I back out and I said to myself, well, on my imaging date at my imaging time, roughly about 11 o'clock at night, it will be above the horizon. Not only above the horizon, but it's going to be almost due south here, which means it's at its highest point as it arcs across the sky. In other words, prime for targeting. So that's how I picked this asteroid. So again, I shot all the subs, and I ended up with this JPEG here, right there. And that's what I ended up with. So the first thing we're going to do is we're going to load this JPEG. This is my process JPEG. Let me minimize Stellarium here. We're going to load this up to a website called astronomy.net. And basically this website plate solves. That's what they do. They have some background imagery taken from a multitude of telescopes ground-based, and I think maybe even the Hubble contributed. And it's called the Digital Sky Survey. And you can see that in different areas. There's a university in France that uses the whole Sinbad applet to do some sort of plate solving stuff too as well. The databases and the background processing that's used by this website is also, you can link to it through your imaging and sequencing software. For example, Sequence Generator Pro plate solves through this same, not necessarily website, but through the same back the back programming that's used by this website. Sequence Generator Pro uses as well. So does SharpCap Pro. So if you're familiar with plate solving there, it's the same thing here. So we're going to click upload, and really what we're going to do, we just want to get a big picture of where we were looking at in the sky, and then we're going to examine that photo for anything that looks like it doesn't belong there, if you know what I mean. So we're going to go choose file. Here's our JPEG, and we're going to hit open, and we're going to click upload. This usually takes a little bit of time for it to even accept the upload. So I'm going to pause while it's doing that, and I'll come back to you. All right, back with you. It is uploaded, and it's currently processing. It's actually in queue to process. I can't imagine the number of people that upload images. So ours is in the queue to be processed. This page is what will come up. Here's the submission number. You see that's a lot right there. It's about 4.4 million. And this will refresh every 10 seconds. And if you decide to quit, you can always hit stop or just close the tab. But we're going to wait for this page to change and tell us that it was successful in finding a match. In fact, I think it just did. No, it still says processing. So we're going to hit pause, and I'll come back to you when it's done. All right, gang, we're back, and this is what we're looking for: success. Of course, it's green, which is always good. So we're going to go to the results page, and this is a bunch of data about what it used to find a match. But what it did, it plate solved. It kind of knows stars, but it takes those stars in our image. And I don't mean the big, fat, plump, juicy ones. I'm talking about the little bitty dim ones that subtend maybe a pixel or two in our image. And then it takes all those and it forms geometric shapes, pentagons, hexagons, maybe triangles, maybe some sort of, I don't know. But those are the primary objects it will form. And then it takes those geometric shapes and looks for, in geometry, if you remember in geometry class, it was called similarity, right? I can have two triangles that are not identical, but they're similar. And we use that to go find similar objects in this worldwide database in the digitized sky survey. And then when it finds a match of those objects, it translates our image as required, turns, rotates, and scales it. I guess turn and rotate's the same to match it up. So let's go to the results page, and we can call up FITS files that it generates FITS files for us. That here's the stars I detected in your image. Here are the stars that I found in my image, and then here are the stars that I found that correspond. In fact, I'm just curious. I'm just going to download that and look at it later. But I always go and view in Worldwide Telescope. This is just kind of a Google Earth of the stars, if you will. Much like we do Google Earth, we can do that of the sky. And so that is where it's at. Sure enough, there's our image. I'm going to zoom back out. It likes to just fly right on in there. And there's our image. And of course, we had a little bit of background ambient light versus their high quality, big old giant telescope image. But that's their image in the background, and here's ours. And you can see this image crossfade slider. I can turn ours on and turn ours off. We can go back and forth real quick. In fact, that's a process called blinking where we can do that. That's how Clyde Tombaugh discovered, if that's the term you want to use, Pluto. In fact, he used glass plates to do that. So, and what's cool is that this DSS, this digitized sky survey, is very, very high quality, pinpoint stars. And so what I'm going to do then is just pick a section here, and I'm looking for stars that we imaged that aren't on theirs, which means it's not a star. So for example, I may look at this bright one first of all, and then turn our image on and go, yep, we got the bright one, they have the bright one. So at least I know there is a correspondence. This website did do, astronomy.net, did do a good job finding where in the sky our image is at. And then I just turn this slider on and off, on and off, and on and off, looking for something that is in our image. For example, maybe that is not in theirs. But when I turn ours off, there's a star there in their image. So, and there's one in our image. So that tells me it's a star. That's not our target. So we're looking for something we captured that they didn't. That's the key. By the way, here's that galaxy right there. Go on, slew over. Here's that galaxy in our image, and in their image, sure enough, look how crisp and clear their image is. That's amazing. But what's cool is we did capture a barred spiral galaxy. So I'm just looking for stuff in here. Now, I'm not going to go through this process with you because I actually do it for about an hour, if not longer, and looking. And I zoom in and I go to small little sections, and I methodically go through this thing back and forth, left and right, left and right, left and right with a slider to try to find something. You know, it's cool. I got a bright star here with a dim one next to it. It makes you wonder if that's a binary. And then as I do the slider, that star really didn't... that binary, if that's what that is, really didn't move that much. Do it down here. So I go around and I just do this everywhere. I will tell you also, because we're going to refer back to it later, notice that if I barely have something in my image, I hope you can see that, but there's something just barely in my image. If I turn my image off and go to their image, in their image, it's definitely there because their image is much, much higher quality, right? So that's an important point that we're going to come back to later. What's interesting, though, if you do come up here, sometimes you'll see this. You'll see stuff that moves. Now, all of my stars move just a little bit to the lower left relative to theirs. That could be due to optics. It could be due to atmospheric distortion of some type. And it could also be due to parallax effect. In other words, the scopes that they use to build this part of the sky in the digitized sky survey were maybe in Australia in August, and I took this picture in April at a much higher latitude. That will create a little bit of positional differences. But every now and then you'll find something that moves a lot more than just the shift that all these stars are doing. Notice all of them are moving kind of to the bottom left, kind of to the left a little bit. But look right here in the middle. Look at this guy. Look what we discovered right here. A big shift. Not only is it a big shift, but it's in the direction completely different from the other stars. It's moving to the lower right and not the lower left. You can see this guy here moves quite a bit too. In fact, more than the others. I wonder if that's not a candidate for something. But the point is, we've imaged a high, what's called a high proper motion star. Stars move, we know that, but because the distances are so great, we don't see it. It takes 10,000 years. You go into a coma, you wake up 10,000 years later. Oh, the stars look like they moved a little bit. It takes a long time to see that movement. with the following two exceptions. One is some stars just move fast. Barnard star is a great example. It has the highest motion relative to our vantage point of any other star out there. The other thing that can cause stars to appear to move is what's called the parallax effect. And for us to be able to see that effect, that apparent movement of stars due to parallax, they have to be relatively close. And sure enough, this star is probably fairly close as far as stellar standards are concerned. And their image was probably taken, for example, at some month in the year, and mine was taken on the other side of the calendar from that month. For example, maybe theirs was taken in August and mine was taken in January. So with the Earth being on the other side of the sun, you have that parallax effect going on, and you can Wikipedia, Google it to learn a little bit more about parallax. The point is, we've captured a high proper motion star here, which is pretty cool, and we can go do some digging around and find out what that is. This one appears to move a little bit too up there, but of course they're all moving to the lower left, so that's why, and this one to the lower right. That's why I know we have captured a high proper motion star. That's pretty cool. But that's not what we're looking for today. We're looking for what? An asteroid. So I'm looking for something that is not in their image, but yet it is in ours. And I have spent a lot of time on this image and I didn't find it, this particular target. You may go out and image a brighter asteroid. You may go out and heck, image this one, or image Pluto, for example, and use this technique. Get to this step, and sure enough, in your image right here, you're going to have something. Let me get here. You're going to have something here in your image, and you're going to slide it off, and it won't be in theirs, and boom, you found your target. But in this case, because this asteroid is very dim, and we may not have even imaged it at all, we're going to have to go on to the next step. So again, sometimes you can stop right here and go, boom, there it is. And sometimes you have to take it one step further, which is what we're going to do. So we are going to keep this tab open because we're going to come back to it here in a second. I'm going to open up another tab and another instance of astronomy.net, and we'll come to it here in a second. I'm going to go ahead and close this Objects in Your Sky website. We don't need that anymore. And we're going to go back to Stellarium. Remember, Stellarium, when we searched for that object, 1997 Uniform Juliet 7, it told us the thing was right here. So that's where it said the asteroid was at. In fact, if I zoom in a lot, let me center that up. If I zoom in a lot, it actually puts a little dot there and says, yep, that's the asteroid. If I zoom out, here we go. Now, this video is not a lesson in Stellarium, but you can set up Stellarium up here under Sensors and Cameras. You can set this up. If you click the little tool here, you can set all this stuff up. Let me bring this over. I can go sensors, set up camera types and whatnot, various telescopes, enter in all the parameters, and it will put a field of view around your target, which is what we have here. So the setup I used to image this asteroid that particular night, I have entered in here, and this is the approximate field of view around that asteroid. So this is where it kind of gets goofy, and I thought of this one night when I was actually trying to go to sleep, and I said, I wonder if this will work, and sure enough it does, so I'm going to show you. So this is where Stellarium says that asteroid was. So what we want to do now is ask ourselves, are we even in the right piece of sky? We know we're in the right hemisphere. Perhaps we know we're even imaging in the proper constellation, because that's what the worldwide digital thing showed us. If we zoom out here, you'll see your constellation line. So we know why is this thing hesitating? We know we're in the right piece of sky, but how do we know that the asteroid actually isn't over here somewhere? We don't. So that's why we got to take it to this next step. All right, so here we are in Stellarium, and what we're going to do is, this is kind of a goofy, unconventional approach here, but what we want to do is capture the region of sky in a JPEG of where Stellarium said the target was, the asteroid 1999 Uniform Juliet. It's important to have your parameters set. So if you need to go back and look at the FITS data or the EXIF data or whatever you want to call it for your images, make sure you've got this set. Even being a day off or a few hours can make a difference in terms of how quickly and positively you can identify your target in the astronomy.net website. So now with this selected, and by the way, I've got a field of view set up here. This isn't a lesson on Stellarium, but I can come over here and put in my telescope, put in my camera or sensor, whatever you want to call it, and it will build a field of view for me. So this is the field of view around the asteroid according to Stellarium. So this is where it gets a little unconventional. I'm going to get the snippet tool here. I'm going to click new, and I'm just going to grab a screenshot, a snippet of these stars inside that field of view. And notice I didn't grab the red box that defines the field of view. Now I'm going to click save, and I'm going to call it Stellarium Location. We're going to overwrite. There was one in there called that already. We're going to overwrite that. Just minimize this. We're going to minimize Stellarium. This is Pixin site. We're going to minimize that. So now let's go to, this was the astronomy.net. Let's open up another instance of that because this has our image in it, and we want to open up an image, or process an image of that Stellarium capture. So we're going to choose File, Stellarium Location, Open, hit Upload. And just like the last time, it takes a little bit of time for this thing to get in line, to be processed, and then to be processed and then show us the results. So I'm going to hit pause while it's doing that. All right, awesome. It found a solution. So we got the green success label there. We're going to go to results page just like we did with our image. We're going to call this, by the way, the Stellarium image, and we're going to call the other one our image. Just like we did with our image, let's go to View in Worldwide Telescope. And it's going to pop up and slew to that location in the sky that our Stellarium picture, and it wants to zoom in automatically. It'll do that here until you can stop it. Now, what I like to do is first zoom out first. Let's go to our image and zoom out and just ask ourselves, are we even in the same dadgum piece of sky? I mean, that Stellarium said that the asteroid was in, and sure enough, we are. We got some constellation lines right here. You can see this red line. I think, is this Booties? I can't remember. But you got a red line here. Let's just call this line 1 unit of measure. And in fact, if we go 1 unit of measure along an extended center line of this line, you can find that we are in the right piece of sky. So that's pretty nice. This Worldwide Telescope page sometimes will circle DSOs. Sometimes it doesn't. I don't know why. Sometimes it'll put a circle here and one here and not one there, but yet put one over here. Whatever. Sometimes if it'll do them on both of the Stellarium image and ours, that's great. But the point is, we know we're at least in the same constellation, and not only that, we're in pretty much the same piece of sky within that constellation. So the next thing we're going to do is we are going to walk our way from a prominent location in this piece of sky, whether it's bright stars or galaxies, walk our way from that known location, for example, these two bright stars, to our Stellarium image, where Stellarium says the asteroid should be. At the same time, we're going to do that with ours, okay? So these two right here stand out, these two bright stars. So let's pick the second of the two, put our crosshairs on both of them. All right, now we're going to zoom in. Not too much. We'll zoom in here. Now we got a little triangle here with the apex of the triangle pointing to the right. Let's come over here, see if we can see that same geometric form. Yep, there's a triangle. So let's go to the upper star of that triangle. I don't know if you guys can see that in this video, but it's right there. You get the idea. We're just going to walk our way closer and closer to our Stellarium image. Again, let's see where that is. It's up here. Okay, so now we need to kind of go up in that direction. This thing that turns on and off up here is aggravating. So I have a line of stars. It's going to come on again. A line of stars right here. And let's look at the most southern of that line, kind of a line of stars here. Let's see if we can find it in our other image. Let's zoom out. Sure enough, it's there. So let's walk our way to that southernmost. It almost looks like a galaxy. So walk our whatever it is. We're going to walk to it. Now let's zoom here. Now this is a Stellarium image, if you'll recall. And it says there's some stars there. So let's see what the DSS has, that Deep Sky, Digitized Sky Survey. Sure enough, there are some here. Let's make a jump over to this bright one. But first we got to identify it in our image. Let's see if we can do that. Let's go in here a little bit. Is it there? Yep, it's right here. So it's right there. And you guys see whether you can see it actually in this video or not, you get the idea of what we're doing. We're star hopping is basically what we're doing. We're going from a very bright, prominent set of stars to some dimmer ones, walking our way along. So now let's turn on our image, turn on the Stellarium image down here, and we should be in the same piece of sky. So Stellarium says that the asteroid Stellarium isn't going to show this galaxy that's up here. Let me zoom in a little bit more. Notice I don't want to get my crosshairs off my reference star. We walked our way, you know, because you can get lost. So Stellarium says the asteroid's right there. Look, there's a galaxy there and then a bright star. So let's see if we can find that in our image, or rather on our tab. So there's a galaxy and a bright star in ours. So we found it in both. So let's slew to that bright star underneath the galaxy. Galaxy, bright star. So let's slew to it. And then to verify, I'm going to zoom in. Sure enough, we have this triangle form here. That's on our tab, and then on the Stellarium tab, a triangle. So now we know we have both tabs looking in the same piece of sky. Let's turn on the Stellarium image, and it says our asteroid, if we zoom in, again, I don't want to drag the crosshairs off our reference star. If we zoom in, the Stellarium says that, hey, if you take these two pointer stars and call that 1 unit of measure, and flip down 1 unit, maybe 3/4 of a unit, and then slightly down, this is where the asteroid is. And sure enough. So just so we don't get lost, let's slew to that star first. Let's do the same here. We'll go back to the Stellarium image, turn it on. And sure enough, I'm going to actually go 50% Stellarium on this slider here, down here, so I can still see the crosshairs and see the background stars from the digitized sky survey. So Stellarium says if you go about 1 unit of measure, that's where you'll be. 2 reference stars, 1 unit of measure. So let's do the same on our image. So here's our 2 reference stars right there. So we're going to go 1 unit of measure. Boom. Stellarium says the asteroid should be right there. And I zoom out, and is that in our camera's field of view? Sure enough, it is, and I'm happy with that. So based on, at least we imaged that chunk of the sky that Stellarium says the asteroid is in. That's good news. So this is, again, the Stellarium tab and Stellarium image. I almost don't need it anymore. I'm not going to close this window because I don't want to have to start that search process over, but we're just not going to use this tab for sure. We're now going to stay on ours. So now that we know where Stellarium says that asteroid should be, it should be in this area here. So I'm going to go back to the blinking process, on and off, looking for something that has a high degree of movement. An example of like a planet as far away as Pluto, or a high proper motion star. But in the case of an asteroid, it will not be there on the DSS and then be there in our image. And we talked about that already. So I'm going to focus my search in this area that Stellarium would said. Remember earlier when we were doing this blinking technique, we were kind of scanning this whole thing, right? And when we couldn't find it, we had to narrow the search down to a very, very regionalized part of the sky based on Stellarium. And that's what we're doing now. So we're going to get in here. And not only that, we're going to look for some really, really dim things. And I'm not going to do this whole process with you watching here because you would die of boredom. But bottom line is I did this for quite some time, and what I found was this object right here to the right of the crosshairs. That object. Watch what happens when I turn our image off and turn theirs on. So theirs is on, ours is off. So us, them, us, them, us, them. Now let's go back to us. This is where it's important when I talked about the quality of their imagery versus ours. Whatever this object is that I think I see something. If it is indeed an object that should be permanently there, i.e. a star or a galaxy, then guess what? Their imagery definitely is going to show it. And it doesn't. So let's confirm that. We're all critical thinkers in this hobby, otherwise we probably wouldn't be in it, right? So let's turn our image back on. This is the suspected asteroid. Look at this guy over here. He's just about as bright as what I think might be the asteroid. So is this guy here and a couple others here. But let's focus on this one here. If we turn our image off, leaving the DSS in the background, watch what happens to this object. It's actually a pinpoint star. The point is, in our image, if these two things are, for the most part, they look identical in our image, then it stands to reason that if we turn our image off and go to the DSS, those two items would also look identical. In other words, where we think this asteroid may sit over here, on their image, there should be something just as bright. In other words, another one of these should be sitting over here, and there's not. So that tells us that not only did we image something, but we imaged something that was there when we took the picture, but it wasn't there when they took the picture for their DSS. So it could be a whole host of things. It may very well be another asteroid, as far as we're concerned. I mean, who knows? Is it noise? No, because we would see that effect randomly distributed throughout we would have detected some movement a long time ago in that first step that I talked about. Also, remember, the more subs we take, the greater the signal to noise ratio. So just by virtue, what we take, 18 or 8? Yeah, 8. So just by virtue of taking and processing 8 subs, we have gotten rid of a lot of the noise, not all of it, but a lot of it. And there's definitely, and why does your eye and my eye see something here? Because it stands out relative to the background. So we've reduced that background noise enough for this thing to stand out. So based on the fact we know we've imaged something, we know it's at the approximate predicted location of Stellarium, where Stellarium says, in fact, it's dadgum close, very, very close. It's almost too coincidental for it to not be our target asteroid. And then the last thing I ask myself is, well, then why doesn't it look like one of these over here? Well, I don't know what stars these are, and I don't know if I could go and ever even hope to find out. I'm sure I could go into the what do they call it, the Sinbad simulator, and click on it, and it will tell me the magnitude. The point is, whatever this is, we know it's extremely dim. And if we go back to Stellarium with that asteroid called up, it'll tell you over here, that asteroid, when we imaged it, was at magnitude 17.7. You might as well call that 18, right, for all intents and purposes. But that is dim. That is about 18 millionths. That's 18 million divided by 1. I'm sorry, 1 divided by 18 million. That ratio, about as dim. If I could get this right, I don't know why I'm sounding like an idiot. An 18 millionths as bright as Vega, this object here, according to Stellarium. And if we go back to our tab, yep, this object is indeed dim. So sorry about the verbal catapulting there, trying to get that out. But you can see, again, just to reiterate, if it's barely visible, whatever it is, my suspect target here, asteroid, is no different than this object right here, whatever that is. So if I keep an eye on it as I turn off our image, the DSS has a clear, discernible pinpoint star there. So that tells me if this were a star, it would show up in their image, and it doesn't. So I can rest assured and say with a fairly high degree of confidence, we have successfully imaged Asteroid 1999 uniform Juliet. Folks, that's it. I hope you enjoyed it. Sorry about fumbling through some of the stuff there. A little bit of a lengthy, 40 minutes, but hopefully you learned something. Maybe you can use this same process to go out and image some really, really, really challenging targets, some really, really dim DSOs. There's some quasars out there. I've imaged a quasar before. And then obviously you can go out and you can do the same thing with Pluto, and obviously do the same thing with asteroids. So I can say that you and I have successfully imaged, processed, and identified Asteroid 1999 uniform Juliet right there. If you guys like this, I always enjoy entertaining questions and comments. So put them down below. Also, I've got a lot of other astrophotography related and astronomy related videos on this channel. If you liked it, click like, and I'd ask you to subscribe. So you guys have a great day. Bye.